Hey guys, I'm Yari Dareglia of Jump Zero. Today we'll have a look at some really interesting and important topics, classes and objects. I'll show you how to write classes, how to instantiate objects with a designate and initializer, and then you'll learn how to use the self and super keyword. We have a lot to talk about today, but please note that you need to have basic knowledge of object-oriented programming before moving on with this lesson. This is out of the scope of this course, but I'm sure you can find many information and tutorials about this topic on the Envato network. Okay, let's start by introducing classes. In Objective-C, we split the class definition in two different files. The header file is the place where we put every public information. You have to look at the header file as a document that you can give to other developers to describe the class. In fact, in this document, we put the prototypes for functions and variable definitions. The implementation file is where you make things work. Here you write the body of the function, private prototypes and variables. These two files have different extensions, .h for the header and .m for the implementation. Now, create a new command line tool project so we can start writing our first class. As we understood from the previous lessons, I love video games, so let's create a class to describe a simple player with a name and a total score. Add a new file to the project and select from the template's Objective-C class. Be sure that it is subclass of NSObject, that is the root of every Objective-C object, and name it player. Okay, Xcode has created two files for us. Let's open the H file and have a look at the syntax. The declaration of a class begins with the directive @interface and ends with the directive @end. Then we have the name of the class, and after the colon, its superclass. In this case, the NSObject, a root class that defines the basic framework of Objective-C objects. Now look at the implementation file. In this case, we find the directive @implementation with which we create the implementation code for our methods. Okay, we can now add the needed information to our class. Again, open the file player.h and instance variables must be enclosed in curly brackets. So let's add the brackets and insert two instance variables. An integer variable for the score and a string for the name. And a string is a class used to create strings in Objective-C, and as you can see, we refer to it with a pointer. These two variables are automatically defined as protected, so to access those values outside the class, we need to create accessor methods. We can define the prototype of these methods directly after the curly brackets. Let's create what is called the getter for a score variable. Is an instance method, it returns an integer and it's named exactly as the variable. Now let's define the so-called setter for the score variable. Doesn't return a value, its name begins with set and the capitalized name of the variable, and obviously it takes an integer as parameter, because score is an integer too. Remember that when you create accessor methods, you must follow these naming rules. Now we can open the implementation file and add the code for accessor methods just after the directive @implementation. The setScore takes the new score value as parameter and assigns it to the score variable, while the getter method simply returns the current score. And the same logic is at work for the variable name. Okay. We have just created the class player and we can access to the value of its instances with the shown accessor methods. I guess that you are thinking this way will be a pain for more complex classes, and you're right. But don't worry, because in a couple of lessons I'll show you how to use some directives to avoid all this code. Now that you know how to create the class methods, I can show you how to add private methods to it. I told you that the interface is used to add information that you want to give to other developers, for instance, so you don't need to get into details about your private methods. And in fact, you can add the prototype of these methods directly in the implementation file with this code. You must rewrite an interface block and add empty parentheses at the end. This is called class extension, and you can implement its methods directly into the next implementation block. Within this method, we reset the name and score value to an empty string and 0. We will return on this method later to add some more. Let's see how to create an instance of our class player. Open the main.m file and include the header of the player class. Now that the interface is included in the main file, we are able to use the class player. So create a new player with this syntax. In this call, the most inner block reserves the memory for a player instance, and then it initializes the object with the init message. This pattern is called two-stage creation. Now, we can access the variable for P1 in two different ways. We can use the accessor methods, so for example, we can set the name sending to P1, the message setName, or we can use dot notation. And this is exactly the same for the gather method. We can print the name of the player through the nslog function. And in this case, the %@ is the wildcard used for strings. Now let me show you an interesting way to describe an instance by a string. You can override a method defined in the NSObject class called description. To override a method defined in a superclass, you just have to define it in the implementation file. So let's implement the description method. This method returns a string, so let's use the stringWithFormat function of the NSString class to create a new string. It uses a template string, as the nslog function does, and it substitutes the wildcard with the value passed after the format string. Now let's open the main file and change the nslog output. Compile, and you get a description method for our class that will be executed. When you call name and score within the description method, you are directly accessing the variable. This is not exactly good practice, because we also have the accessor methods, and we have to use them to be consistent with the class pattern. In many object-oriented languages, we can use keyword to refer to the instance. In Objective-C, we use the keyword self. So we can modify the definition of description by using the self keyword and be sure that the accessor methods will be called. It's possible either to use the dot notation or to call the accessor method. It's up to you. Remember also to correct the resetValue method adding the self dot notation. The only place where you have to access the variable directly is obviously within the accessor methods. Let's see what happens if we use self in the name methods. As you can see, it generates an infinite loop, because self.name calls the getName method, and so until the application crashes. To design a better class, we can implement a custom constructor that directly receives the name and the score as parameters. Let's add the prototype to the interface. We return a player object and we get the needed params. Let's call this method init with name and score. And now I'll show you something really odd. The first time I saw this definition I thought it was an error. So, to create a new instance, you must start by initializing the object through the self keyword this way. It will sound unusual to initialize the reference of the self object, but this is the standard way to create a new instance in Objective-C. The super keyword refers to the superclass, in this case the NS object. So we start by creating a superclass object. Now, if the initialization is done, we can set the other parameters this way. So we check the initialization and we put the values into the instance variables. Then we return the object. Remember that the method that calls the superinit is called the designated initializer, and your class should have only one designated initializer. So what if we want to create a second initializer? Well, no problem. As an example, we can create a simple version of the previous constructor that instantiates player only by name. add this prototype to the interface. This function only receives a string and returns a player. I told you that you can't use superinit because you already have a designated initializer, but the unique way to correctly initialize your object is passing through the superinit method. So a good solution is to use the designated initializer in your secondary initializer. Let's see how. We start by creating the new function as usual, and then I call the designated initializer with the name received in this method, and I set the score to 0. This way you are sure that every object created for the player class are passing through a shared method that you can use to set required data. Let's see how to use this initializer in the main file. I can create player using the initWithName method and the initWithNameScore method. Okay guys, this is the end of this lesson. You can try and play with this file to create some other methods and maybe a totally new class. Hope you enjoyed it. Bye and thanks for watching.